This is a guided reading for AP Physics, Chapter 18, Sections 6, 7, and 8, and a little bit of additional information. Go ahead and open up your books to page 523. I'm assuming that you've already read sections 1 through 5 and done that guide reading. If not, obviously do that before you look at 18.6. But take a look there. You are going to read all of 18.6, but before you do, a couple of things I want to make sure you pay very careful attention to. Okay, this is all about electric fields. And one of the key things is that to visualize an electric field, you pretend you have a small, very, very small positive test charge at a location. That helps you to get the direction of the electric field. Okay. In class, either before you are listening to this or the very next day, you will get a good way to visualize electric fields in 3 dimensions with the magnet and the lead filings. Okay. You shake it up and put the magnet in, and you'll see in 3 dimensions the curves and all that. Electric field lines aren't really there. They're just a way for us to visualize what's happening if something was there. There aren't actually literally lines running through the sky between 2 objects or anything like that. It's just a way for us to visualize things in 3 dimensions. It's a tool that we use to solve problems, but it's something you need to be able to visualize to figure stuff out and to answer questions right and to get a grasp of what's going on. So it does help to picture them in the air between 2 objects. Okay. Or point charges or whatever it may be. Take a look at page 524, and you'll see the definition of an electric field. It's a force divided by that test charge. Okay, so whatever direction the force is in on a positive test charge, that's the direction the electric field will be in. So this is a new type of quantity. It's a force divided by a charge. We have not talked about fields before. We could have talked about gravitational fields, but we always related that to forces. Okay, so go ahead and read 18.6. All right, welcome back. If you didn't take a chance to look at the example problems, please do so and pay careful attention to the signs and when they're using absolute values and the magnitudes of things. Spend probably a good 20-30 minutes going through the example problems to start to get a grasp on how electric fields work. All right, we'll be doing more with parallel plate capacitors in class, but that equation that's on page 527 is really the gist of most of what you need to know, along with the picture on the bottom right of 527. Okay, take a look at 18.7. And 18.7, you're going to read all of it again, but pay careful attention to the pictures and spend some time thinking about the directions of the arrows and where they're starting and where they're ending, and you actually are responsible for certain pictures in terms of the field lines and what they look like. So before you read, take a look at the bottom of page 528. The picture for the electric field lines coming out of a positive test charge, you need to know that. Look at the bottom of page 529. There's a positive and a negative point charge separated by some distance. You have to be able to recreate that. Okay. Take a look at the top right of page 529. There's for a negative test charge. Okay, similar to a positive test charge, except the field lines go in. You have to be able to draw that. Okay, and then there's one more scenario that you have to be able to draw, and that's on the top of page 530 when you have 2 like charges. Okay, and you'll see there's an area in the middle where there are no field lines, and that should make sense after you get done with the reading. And if you switch that to 2 negative charges, it's the same thing. The arrows just point in. Okay, those are the ones you should be able to draw. Now you're going to see some other ones like figure 18.28 on page 530. Okay, you should be able to figure out at a point what an electric field is, but to be able to just draw those lines without picking some points, that is not expected. So those more complicated ones with 4-point charges, just drawing the field lines, you don't have to do. You should be able to tell if they're reasonable, if they're given to you, but you don't have to produce them as far as in any question I've ever seen. Go ahead and read 18.7 and then come on back. Welcome back. 18.8 is a fairly difficult concept to grasp. I am going to have you read it. We will talk about it in class. Before you do that, let me explain the picture a little bit. Look at the top right of page 531. You'll see a solid conducting sphere, and they're trying to get you the idea that the net charge is on the inside of the sphere. And if you have a net charge on the inside of a metal conducting sphere, Okay, what are the like charges going to do to each other? They're going to repel. They're going to try to get as far away from as possible. Now, this is a slight oversimplification. Okay, it's not like there's a bunch of electrons sitting in the middle of the sphere. Okay, this is all happening on the molecular level by rearranging of molecules and stuff like that. But from a net charge perspective, it's like we have a bunch of negative net charge. It'll spread out and get as far away as possible, and will turn into the picture right below it, where all the charge will be distributed on the surface. If all the charge is distributed on the surface, there will be no electric field on the inside, and there will be no net charge on the inside. Okay, so go ahead and read 18.8. All right, welcome back. 18.9, Gauss's law, is not on the test. There will be one or two things we'll take out of that once we get to some electricity and magnetism stuff where we talk about changes in fields or fluxes, but this stuff isn't on there, so you don't need to read it unless you're really interested in it, and some of it might not make a lot of sense unless you have calc anyway. Take a look at 18.10 on page 536. If you've ever wondered how copiers and printers worked, okay, and I've actually seen questions on free response that are based off of how a copier or a printer works, you can read this. It's not any additional concepts other than explaining, it's like a how stuff works type thing, okay? So you can read 18.10 if you're interested. All right. Welcome back if you read that. 18.11 is some additional practice problems. They're both relevant. I would take a look at those. They're both fair game for the test. So spend 10 or 15 minutes taking a look at their solution and how they walk through it, doing the geometry and the components and everything else of the electric fields and the forces. That concludes this guide reading. Thank you.